Hi friends, today we are looking at an interesting problem from set theory, which is part of all competitive exams like SAT, Olympiad, and so many other exams. The question is this: there is a set like A containing 7 elements, and you're asked to find out the number of all subsets that you can form from this set. Let's take one by one all the subsets and then total up all of these subsets to answer the question. Let's begin with subsets containing just one element. For example, if I write a set like this with just one element, that is certainly a subset of this. Now, if you take another one, B, that will be another subset. Like that, how many subsets you can form? 7 subsets. So number of subsets with just one element is actually 7C1, which is nothing but choosing one element out of 7 elements, which you can do in 7 different ways. By the way, some basic idea from permutation and combination are presupposed when discussing the solution. I hope you're familiar with those ideas. I will be using it here. Now let us look at subsets containing 2 elements. For example, this will be one of the subsets. Similarly, if I write BC, that will be another subset containing 2 elements, and it will go all the way up to FG. The question is how many subsets you can form. It's not practically possible to list out all the subsets containing 2 elements and then count to find out the number of subsets. There is a simple result from combination which will be helpful to us. See, basically this is about finding the number of combinations of 2 items out of 7 items, which is given by the formula 7C2. So 7C2 will represent the number of subsets containing 2 elements. If you extend this logic, what will be the number of subsets containing 3 elements? See, for example, ABC will be one of them, and there will be many. So the number of all set subsets you can find out using this formula. This is nothing but basically collecting 3 elements out of 7 elements. In 7C3 ways you can do that, and that will represent the number of all subsets containing 3 elements. So what will be the number of subsets containing 4? 7C4. If you continue this process, you can see that 7C1 will be the number of subsets containing 1 element, and let me total up all of them. Then 7C2 will be the number of subsets containing 2 elements, 7C3 the number of subsets containing 3, and it goes all the way. See, 7C6 will represent subsets containing 6 elements, and the last one in which you have all the elements chosen, that is nothing but the given set itself, and it's represented by 7C1. There is only one subset containing all the elements, and now there is one more subset. See, probably you heard of a set called null set. In set theory, usually we represent it by phi. Whatever be the representation, it doesn't matter to us. There is a null set containing no elements, which is considered to be the subset of any set given to you. And how many subsets are there? Only one subset containing no element. And that may be represented by 7C0. In fact, this is actually the number of combinations in which you are choosing no element out of the 7 elements. So let me add that to the sum you have already considered. So this will represent no element. This will represent subsets with 1, 2, 3, all the way up to 7. And the sum of all these numbers will give you the total number of all subsets. So this is the final answer. Now, how do you sum up this number? See, there is a simple formula which I'll show you now in combination, which says NC is 0, NC1, NC2 plus all the way up to NCN is given by 2 power n. There is a simple result like this. If you apply that here, plugging n equal to 7, what will be the final answer? See, 7C0 plus 7C1 7C2 all the way up to 7C7. That will be, put n equal to 7, you will get 2 power 7. And 2 power 7 is just 128. So 128 will be the number of all subsets you can form from the given set. You can generalize this idea to find out. See, supposing a set has n elements, then what will be the total number of all the subsets you can form? 2 power n. See, you don't have to work it out these different steps. If you know the number of elements in a set, the total number of subsets will be given by 2 power n, where n is the number of elements in the given set, which you can do in just a few seconds. I showed you the long form to show you how you arrive at this formula. Given a question of this kind, you don't need to go through all these steps. You can immediately write the answer as 2 power the number of sets in the given set to get the number of all subsets. In this case, it is 2 power 7, and the final answer is 128. If there is any point you are not so clear about in the solution, leave your remarks in the comments below. And also, if you like the solution, please hit the like button and subscribe to my channel. And also don't forget to press the notification bell so that you'll be getting many more interesting problems, not just from set theory, from all areas of mathematics in future. Thanks for watching and see you in the next video.